Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And in this one, again, we're coming to the close of quarter three. We're coming to the close of our Pythagorean theorem. Again, make sure that you're going back, being able to pronounce that word and that phrase as much as possible. So we're closing this out, and we want to be able to work with some of these word problems, as a lot of people say, well, I can't do word problems. And my response is, it's hard to move a boulder when you're not pushing. So unless I see your pencil to the paper or whatever you're writing with, it's going to be difficult, of course. So what we're going to try to do for this, at least, is I will do the first one the whole way through. I will set it up using the drawing. I will show my work, as always, in this space, and then I will have my answer with a label, so whatever units I have that are in there. And so what I suggest you do at the very start is, since we are talking about the Pythagorean theorem, we want to have this at the very top. You can say it's going to be a squared plus b squared equals c squared. That way you can already remember, okay, I have my side length squared and another side length squared, meaning the two legs squared added together is equivalent to the hypotenuse squared. So again, make sure that you're able to write this out first, and then you can approach these problems. So what I'm going to do is I'm going to read through this once. I'm going to, underline or highlight anything that I need to that would help me set up this picture. Because again, the picture is going to be the most important part, because it helps you identify, where the hypotenuse is, what legs you have, and specifically what value you are looking for. All right, so it says, for the first one, it says, what is the length of a garden hose that is stretched diagonally, corner to corner, across a yard that measures 72 meters long and 60 meters wide? And it says, round to the nearest meter. All right, so it's asking what is the length of the diagonal. So anytime you see the diagonal, it's talking about this right here. Okay, so you're saying from corner to corner. So if we had a right triangle, we're talking about the hypotenuse. Again, the hypotenuse is the side that is opposite of the right angle, and so we're saying that the yard, or the area that you're talking about, it's 72 meters long and 60 meters wide. So that means our hypotenuse is what we're looking for. So you have your drawing, and now to show for the work, again, we have our formula, or our Pythagorean theorem. So we have a squared plus b squared equals c squared. We want to plug in the values that we do know. Again, our leg lengths are interchangeable. That means it doesn't matter if we pick A or B for this, as long as we know that these are the legs and this is the hypotenuse, which is what we're looking for. So let's say that we have 72 squared plus 60 squared is going to be equal to, let's say, instead of c, we'll just let it be x, just to make it a little bit simpler. X squared. All right, so again, using our trusty calculator and driving it carefully as always, I'm going to put it up here actually, so that way you can see it perfectly. All right, so we're going to have 72 squared, so we're going to type 72, and instead of doing times 72 again, we can just hit this little button with it has x raised to the power 2. So we're going to have 72 squared is going to be 5,184. That's going to be plus 60 squared is 3,600. And we have x me try writing that again. We have x squared as it just comes down. X squared. All right. So now I can add those two together. So I'm going to have plus and 5184. All right. So it has this value is equal to x squared. This is, a lot of people have been doing this. They just circle their answer and call it correct. This is an unsolved equation still. We're always looking to find a value for x. So in order to do that, you have to be able to do the inverse operations. And so in order to do that, we take the square root of both sides. Again, the square root is the inverse of squaring a number. And so we're going to say that x, and we can use, since this value is already in here, you just press the square root button, which is right next to it, so get used to using these two. And so we're going to have the square root of 8,784 is going to be 93.7. And you're probably wondering, why am I cutting it off right there? Well, it says round to the nearest meter. And when it says to the nearest meter, it's talking about that ones column. So we're going to underline the ones column and circle the next to the right. So we're going to, since it's 5 and above, get a shove. And so we can say that our answer is going to be about 94 meters. And now we can say, does that make sense? Does that make reasonable sense to get a value of 94? Well, yeah. We have these are our three values, and so since these two are legs, it has to be larger than those two. Again, since it was the hypotenuse, we knew that the 94 had to be the largest of these three sides. Alrighty. So again, make sure that you are drawing it. So again, show the picture. Make sure you're using keywords to find what it should look like. Show the work, and then have your answer to the right.